So hello everyone. First of all, thank you for being here at my presentation, which will be about building technical documentation with reStructuredText and Sphinx. Let's start with a short introduction of myself. So my name is Ryan Badaï. I'm 26 years old. I have a master's degree in networks and telecommunications engineering. And I've been working as a DevOps consultant at DBI Services since 2 years, where my main fields of interest are Kubernetes clusters, administration, Python programming, and Ansible. I have a few certifications like the Kubernetes cluster certified administrator certification or the Prometheus certified associate certification. Let's move on to the main topic. So this is the agenda for today. First of all, I'll start with a short introduction. Then I will focus on reStructuredText, move on to Sphinx, and then make a short conclusion. For the introduction, I will first start with documentation as code, then documentation generators, and summarize the goals for this presentation. So let's explore the concept of documentation as code. Documentation as code is a philosophy that encourages us to treat documentation like code. The core idea is to use the same tools as developers for creating documentation. So this includes issue trackers to manage documentation tasks and improvements, version control tools like Git. You may use something else, but I guess most developers or IT guys are using Git. This allows to track the versions of the documentation. Plain text markup languages like Markdown that you probably know. The topic of today is about reStructuredText that I mentioned here, and we also have, for example, ASCII doc. We also can do code review. So when I'm pushing some code and documentation in a Git repository, I can ask one of my colleagues to review what I did on GitLab. And also, for example, CI/CD pipelines that allow me to lint, build, and deploy the documentation automatically. We have many benefits to this approach. The first one is that whenever we are doing a project with code, the documentation is very close to the code, so we don't need to open a separate tool for documentation and can push the documentation for the newly created code in the same commit, which makes things easier. Then we simply don't need additional tools, so I don't need to open Word or whatever. It's much faster. And most importantly, it forces to write documentation before merging code, because whenever I do a merge request, any of my colleagues can say, oh, Ryan, you didn't write the documentation for this piece of code. Please write the reStructuredText file with the proper documentation. In the end, what we get is simply better documentation quality. Okay, let's move on to the next slide. I will talk about now about documentation generators. Documentation generators are tools that allow us to create and maintain technical documentation. They are mainly specialized software that transform plain text files, images, or source code into documentation in a proper format. For this, we are using reStructuredText and Sphinx, which are tools from the Python community. I will also mention other tools in the end of this presentation. And here is a picture that shows an example of what's going on here. So we can take images, source code, and restructured text files as an input. We have our Sphinx documentation generator, and we can build HTML documentation, PDF, EPUB, Linux main pages, or whatever, as long as there is a plugin to build what you need. Okay, so what are the goals of this presentation? The goals are to understand what are documentation as code and documentation generation tools. We will then discover restructured text and Sphinx. And finally, you will learn why and when we can use those tools. Let's dive into the details of restructured text. So I will keep going with 5 parts here. The first part is, what is restructured text? First of all, from now on, I will mention restructured text as RST because it's quite hard to pronounce in English for me. So RST is a powerful markup language which was developed by the Python community. You can think of it as a more robust cousin to Markdown, because just like Markdown, it uses plain text files. But in this case, we are using the .rst extension. We are using restructured text in many well-known software. So software like Flask or Ansible, which are Python software. So this explains also partly why the Python community is maintaining restructured text. But we can also use this for other kinds of software like Podman, the Linux kernel, phpMyAdmin, and there are probably much more. So it's very flexible, and with it, we can handle complex documentation tasks. Okay, so here is a first example with the Linux kernel documentation. So you can see 2 screenshots here. On the left, you have a sample of documentation from the Linux kernel, which is the index.rst file. It's basically the main page of the documentation. And here you have what is rendered on the HTML documentation, hosted at docs.kernel.org. I can show you quickly how it looks like in the GitHub repository. So here I'm in the Linux GitHub repository. We can go into the documentation part, and here you will see many .rst files. If I click, for example, here on PCI and PCI.rst, I will have the documentation to write Linux PCI drivers. And if I go to the Linux documentation, here is how it looks like. So here I have my article to write PCI drivers. And on the left, there is a sidebar which allows me to go to whatever other part of the documentation. Okay, let's move on. We can compare restructured text and Markdown here. The first thing is that restructured text has a steeper learning curve, but it's more powerful and versatile. It has many advanced features like table of contents or complex formatting options. And also there is one single standardized way of writing restructured text, so it's more simple to know what we need. And restructured text also comes into a given format of documentation, which is created by the Sphinx documentation generator. And the last point is that we have built-in support for extensions. Sorry for the mistake here. So we can extend the restructured text language with new features when needed. Markdown unlike reStructuredText, is much easier to learn, but the drawback is that we have much less features. And also there is a big lack of standards with Markdown because we have many flavors depending on the platform. We can have GitLab Markdown, GitHub Markdown. Confluence also has its own Markdown flavor, I think, if I'm not wrong. And those are usually rendered on the web page of the given platform. Or it can be also software that you have on your computer, like Obsidian. And Markdown doesn't have any standard extension mechanism. So whenever you want to extend Markdown features, you need to implement something yourself without any standard way of doing it. Okay, so what are the features of reStructuredText? The first one is that we have multiple directives for embedding content. So those can be images, for example, or what we call admonitions. I will talk about that later. We can have powerful linking mechanisms between pages and sections. So whenever you need to link a part of the documentation somewhere else, you have built-in features to do that. We can generate documentations in multiple formats without format-specific work. So if I write reStructuredText properly, I don't care about whether I need to build HTML or PDF. It should work directly. We can write a piece of documentation only once and then reuse it multiple times. So this is quite handy because if you have a piece of documentation that changes, this change will be effective everywhere else. Also, formatting violations are catched when you build your documentation, so it allows you to detect the potential errors that you will get. And finally, we also have powerful table creation mechanics. I didn't include all the features of reStructuredText because there are many, but those are the main features that you can think of. Okay, so let's move on to the basics. When we talk about reStructuredText, the first file that will interest us is the index.rst file. So I already showed you an example of this file for the Linux documentation. This file represents the main page of all your documentation. And here I have an example for my project that I created for this presentation, and it looks like that. So you can see here that there is a talk tree, and I can include subsections of my documentations, and then it will be rendered like this when I build the HTML for my documentation. So as you've seen earlier, the Linux documentation doesn't look the same because you can choose a theme for your documentation. You can customize what you have. So that's why it's different. Okay, now I will explain you the basics of reStructuredText, and I will start by paragraph, but I will also explain blocks, sections, and many other things that we have. So if you want to write a paragraph in reStructuredText, it's quite simple. You just need to write text. Indentation is taken in account just like in Python. You can also write italic sentences or bold sentences. So this also exists in Markdown, nothing new for you, I think. Regarding sections, to create a section, we need to underline the title with a punctuation character. We can choose whatever punctuation character we want. However, the Python convention is to use hash, for overline for parts, asterisks with overline for chapters, equal sign for sections, hyphen for subsections, circumflex sign for subsections, and further. So you can make many subtitles as you want. And it looks just like that. So this is the Python convention. If I quickly go back to the Linux example, it doesn't use the Python convention. I can quickly show you again. Give me a second. Okay, so here it is. You see that the main title of the Linux documentation uses equal signs. So actually this is just conventional, but you can use whatever you want. And here is what we get when we generate the HTML. Nothing new, it's just like Markdown. Now let's talk about lists. In reStructuredText, we can create many types of lists. The first one is bullet lists. So we can use asterisks, plus signs, hyphens, and probably other signs to create lists like this. And we can also nest lists between them by using indentation. We can also make enumerated lists. Simply use numbers and a dot. Automatically numbered lists with a dash and a dot. And definition lists. So whenever you need to define a term, you can use those. And here is how it is rendered. A little more about lists. We can create what we call field lists. So we can map field names to field bodies. It's a little bit like database records. And we can also document command line options. This is quite useful when we create a CLI tool. And here is what we get. I think this is quite nice because it gives a very readable output. Whenever we need to document an API or command line tool, we can use that. Now let's talk about directives. A directive is a feature that can be assimilated to a function in programming. It allows us to render specific elements like code blocks, images, or mathematical equations. Here is an example of directive. So a directive always starts with 2 dots at the beginning. Then we have the directive name, a list of arguments, and then the options and the corresponding value. We also have the content of the directive, which must be indented to be at the same level. I will show you examples of directives now. The first example is the image directive. So simply 2 dots, image, and I pass as a first argument a path to an image. And I can use multiple options. In this case, I only used 2 options, which is the width of 400 pixels, and as well an alternative text for people who can't see properly. And then we are getting the following output. The text here is not related to the image directive. Okay, now we can talk about blocks. So in RST, we can have several ways to create blocks. The first one is literal blocks. So they are mainly used to display content exactly as it appears. It preserves everything. It doesn't do any kind of formatting. Then we have code blocks, block quotes, sorry. Whenever we need to quote something in an author, those will be displayed specifically. And we also have code blocks for which we can choose the code that we want to have the syntax highlighting for. So this is also a directive which is named code. And in this case, we are getting the following output. If you pay attention, you can see that there is Python syntax highlighting here by default, but this can be disabled if we don't want to have syntax highlighting at all for the literal blocks. Okay, let's move forward with some more blocks. Here we have doc test blocks. So doc test blocks are used to represent Python interpreter session. So here I'm mainly playing with the print function, and it's supposed to show the results we get in the Python interpreter session. Then we also have footnotes and citations. So those are used to provide additional information or references related to the main content. For those, we need to use a specific kind of directive, which looks like this. And it's displayed like that. So you can see that the doc test block is showed in a specific way, just like if I were in an interpreter. And the footnotes and citations appear like that. And I can reference them somewhere else in my documentation. Then we have tables. So in RST, the tables creation mechanics are more powerful than Markdown because we can have cells that can span over rows and columns. In Markdown, this is not possible. So here we can create much more complex tables. And as you can see, it doesn't look very good. It's quite hard to create by hand. So we can use specific tools to create these tables, like VS Code extensions, or we also have specific web applications. This is the output that we get. So here I'm just demonstrating the difference between the OSI networking model and the 5-layer networking model. And there is also a more simple type of tables, which consists of equal signs, just like that. Then we have admonitions. I quickly mentioned admonitions at the beginning. So admonitions are directives that allow to display text in a specific way to attract the end user's attention. So in this example, we have note, warning, and danger admonitions. And here is what we get on the results. So the note attracts attention, warning, and we have danger in red. So in case you have something very important in your documentation, something not to do, you can simply mark danger, don't do this, otherwise it will destroy something. And as you can see, we can also include a directive within another. So in this danger admonition directive, I can just put an image. In restructured text, we can also do math. In the following example, I'm showing formulas for the mean value of a periodic signal, as well as the Shannon capacity formula. So I simply write the equations using the math directive, and I can also describe the parameters in the equation using the same directive below. And we are getting the following result. So you can see that it's properly displayed with the integral signs and the limits. We can also do fractions, everything which is needed for math. We can even do complicated chemical equations, nuclear equations, or whatever. Even if you don't work in IT, you can use restructured text if you are doing, for example, Python coding for science. Okay, now I will show you inclusions. In the features at the beginning, I was saying that we can write a piece of documentation once and use it multiple times. So here is an example of this. I have a restructured text file where I include another one, which is called images.rst, then directives.rst, and finally conf.py. And here is the result that we get. So the first one is out of scope. Unfortunately, I don't have enough space to show it. Then the directives is shown here. And finally, the conf.py file is just displayed here. So as you notice, conf.py is not an RST file. Actually, I can include whatever I want in my RST documentation. So let's say I need to talk about some piece of Python code. Whenever it will change, as we have the include statement, it will be updated every time we build the documentation. So this is quite handy. If I keep this documentation for, let's say, 2 years and multiple persons change this file, it will just be the last version in the documentation without doing anything manually. Regarding inclusions, we also have another interesting feature, which is the inclusion of HTML parts. In this specific case, I will show you how to include a draw.io diagram in your documentation. So if you don't know draw.io, it's a web application which is very powerful to create technical diagrams. And to include a piece of HTML, we can use the raw directive. You simply need to specify the format, which is HTML here, and give the path to the file. One thing which is important to note is that when you are using HTML, it breaks compatibility with other formats. Because if I include raw HTML, I can only build HTML documentation. If I try to build a PDF, it won't be able to support the HTML code inside, which is just logical. I have a little GIF here to demonstrate what we get from this inclusion of the draw.io diagram. So this is a dummy networking diagram that represents multiple sites for an enterprise network. So whenever you have a diagram, you can put it like that. And whenever you update it in Git and update the diagram, it will be updated when you build the documentation. So you can keep everything up to date quite easily with that. Okay, now let's speak about Sphinx. I will first start with an introduction to Sphinx. So what is Sphinx? Sphinx is a Python documentation generator. So when I say Python documentation generator, it means that Sphinx is written in Python. It doesn't mean that we can only generate documentation for Python code from it. As I said in the beginning, it uses RST files for generating documentation, and we can have multiple formats as an output. We can add multiple extensions to Sphinx when we need supplemental features. So let's move on. For getting started with Sphinx, it's quite easy. We simply need to create a Python virtual environment. Then we need to activate it so that in our shell, we have the proper interpreter from the virtual environment which is used. And then we can use the pip install command to install Sphinx. Once we have Sphinx, we can use the Sphinx quick start command to create a new project. And it will simply ask me a few questions, like the project name, the author name, and the project release. When I answered all of these questions, it will create a structure from my documentation project. Let's describe this directory structure. So the first directory is the build directory. So this directory will contain the documentation once we build it. Then we have the source directory. In this directory, we have to put the different RST files that contain the documentation. So it's mandatory to have the index.rst, which I mentioned in the previous slides, because it's the main page. And then we need to add more files that will be available to describe anything. Then we have the conf.py file. So this is a Python configuration file, which is used by Sphinx to provide its different parameters. We have the static directory in which we can put images or any static elements. The HTML for the draw.io diagram, for example, was in this directory in my previous example. And we also have the templates directory that can contain Jinja templates, because we can also generate parts of the documentation using Jinja, which can be quite powerful when we have very complex use cases. Okay, let's talk about the conf.py file now. So as I said, this file is used for configuring Sphinx. First of all, it contains a lot of metadata, like the project name. We can also put some information about copyright, the author name, the release of the project. We can also choose the different extensions that we want to load into Sphinx. In this specific example, I have only 2 extensions, one which can be used for building PDF documentation, and one which is called Sphinx Click. Click is a Python framework for creating command line extensions. I will show you an example with this after. We can also configure multiple paths like templates and also the HTML theme, which is here Sphinx RTD. So the HTML theme will allow you to change how your HTML documentation looks like. Okay, so when we wrote our Sphinx documentation, we want to build it. For building, we can simply use the Sphinx build documentation. I need to provide the format type that I want, which is HTML in my case. I need to provide the source directory, which is docs source, and the destination for the build artifacts, which is docs build. Once this is done, I can expose the HTML documentation, and here is the result that I get. So I can quickly show you in live what I get. So here I already wrote the Python command to expose my documentation. I simply need to go to the link, and here is what I have. So every example which was in this PowerPoint is in this documentation. Here I can see the main page, which corresponds to index.rst, and I can simply go to the multiple pages, for example, paragraphs, sections, lists, directives, and it's quite simple. There is also a search bar. So for example, I can search test, and here we can see that the test word appears in the blocks section. Okay, let's get back to the PowerPoint. So the next part, which is interesting, is that we can use GitLab CI or any other CI tool to continuously build and deploy the documentation. In my case, I made an example with GitLab. So GitLab allows to deploy documentation with GitLab pages. Here is my GitLab CI file. So I first have a test step which checks that the build doesn't fail, and then I simply deploy directly. And I just get the exact same result. You can see here that there is a GitLab URL, Exchange, building technical documentation, Ryan, blah, blah, blah. Okay, so now I will show you a little bit of Sphinx extensions, because I mentioned that we can extend Sphinx features. One interesting extension is Sphinx Auto API. So this allows to document Python API whenever you write Python code. To use this, I need to add the extension in the conf.py file, as you can see here. And I need to specify the directory that contains the code to document. Here you can see the code that I want to document. So it's very simple. I have 3 different classes with some inheritance relationships, a few methods and their parameters, 1 function, and here is what I get in the documentation. So if I quickly show you once again the page in live, I have this, and I can simply travel the different Python modules. You can see, for example, as this class inherits from the machine class, I can click and it's going to the proper class documentation. So that's one of the modules I wanted to show. Then we have the Click documentation module. Click is a Python library to build CLI tools. And for this example, I built a CLI tool to demonstrate this extension. We can use the Sphinx Click extension. And my CLI just looks like that. Python-m RBA CLI.cli, and you can see how to use it, the different commands that are available, and the options. If I want to document what my CLI can do, I simply can use the click directive, which is now available because I installed the proper extension. And now I quickly show you my CLI code. I have a few functions with some Python decorators. You don't need to know what is a decorator. And then my documentation will be available like this. So you can see that there are the different commands and options available. And all of this is done automatically. One interesting thing is that the CLI documentation is not generated from parsing. It's dynamically evaluated from the CLI framework before building the documentation. So we are actually using the runtime data. And to demonstrate this, I made a for loop that dynamically creates new CLI commands. And here is the result that we get. So here you can see RBA CLI. And there is my command 0, which take the option foo0, command 1, foo1, and this is just exactly what I have in my code here. So whenever we have a use case, there is probably a Sphinx extension for it, at least in the Python ecosystem. And if you have a very specific use case, you can probably build your own extension, or you can maybe use another tool like AsciiDoc. Okay, so this is the end of this presentation. So what you have to understand is when can you use reStructuredText and Sphinx. So whenever you have complex documentation needs, those tools are very handy. When simple Markdown is not sufficient, you feel like you need to do something, but you can't do it in Markdown. It's also especially good for software documentation projects, because as you saw, I can document my Python code automatically. Whenever you need multiple formats, or simply if you want to build an HTML documentation and you know this tool, it just works. There are some alternatives. So the first one is, for example, MyST, which is a Markdown flavor buildable by Sphinx. And we also have AsciiDoc, which is a language, and the given generator, which is AsciiDoctor. I can quickly show you this, and then we can stop this presentation. I'll just show you an example of ASCII Doctor. Okay, so here I'm on the main page of ASCII Doc, and there is a comparison between the multiple languages. So here you can compare Markdown and ASCII Doc. So it's quite similar to RST in terms of feature. We can compare them directly. So the title is more simple in ASCII Doc. You can see that we can also add multiple options for many things, admonitions, make different titles, code blocks. So if you don't have any Python related application or interest, I would say you can try ASCII Doc because it may be probably easier for you to use. Okay, so thank you for listening. If you have any question, I can listen to you.